Okay, so in this podcast I am recording how to do the problems in the density problem set, and I am doing type 2 and 3 problems with the assumption that if you can do type 2 you can also do type 1, and I am on page 16 in the Unit 2 packet, and I am working on problem number 16. So in the Macy's Thanksgiving Day Parade in 2000 there was a new float called Cheerios Buzz Bee. The jar of honey it was holding contained 36,000 some liters of helium. If the honey jar was only 1/10 of the entire size of the float, okay, big float. So what's the volume of the entire float? Well, this represents 1/10, and the whole float is going to be 10 times as much, so I can just add a 0. So it's that many liters. Okay, so if the density of helium is this, we want to know the mass in kilograms. So we're trying to find kilograms, and my given is that I have this much volume, right? So it's, you want to find kilograms of what? It's a float that has this volume. Now, one thing we need to get clear is that 1 centimeter cubed is equal to 1 milliliter. That's an important concept, especially with density. We use it a lot. So I can replace grams per centimeter cubed here with grams per milliliter, and that means the same thing. Okay, so let's start with our given. We have 36,000 or 367,630 liters of helium, and what I know is 1 liter is 1,000 milliliters, and I need milliliters down here to make this cancel. So 1 milliliter right here, 1 milliliter is 0.000178 grams. But I want my answer in kilograms, so what I know is 1,000 grams is 1 kilogram. When I do that, I cancel liters, I cancel milliliters, I cancel grams, and I get my answer in kilograms. And my answer should be, I want 3 sig figs, that's what I have here. Okay, so I'm going to call this 65.4 liters of, or I'm sorry, kilograms of helium. Okay, let's take a look at number 17. Alright, the density of paper is 1.2 grams per centimeter cubed. What is the mass of the paper in the notebook that is 76 millimeters thick by 215.9 millimeters wide by 279.4 millimeters long? Okay, so first thing I recognize is I've got these dimensions here that are millimeters, but my density is given to me in centimeters cubed. So I've got to get the units the same, the length units, and I'm going to go to centimeters cubed so I can use the density, and what I know is that there are 10 millimeters in 1 centimeter, so I can use that. Okay. So, easy thing I can do is just add a 0 to all of these, right? I can move the 0, the decimal point over, and I end up with millimeters instead of, or I end up with whoops, I went the wrong way. So it's going to be 7.6 centimeters, 21.59 centimeters, and 27.94 centimeters. Okay, so what's the mass of the paper given these dimensions? So what I need to do is find volume, and I can find volume of some regular shaped object is length times width times height. So if I use my 7.6 times 21.5, and this is centimeters, this is centimeters, times 27.94 centimeters, I end up with units of centimeters cubed, and I get, this is just 2 sig figs, which limits me, so 4,600 centimeters cubed. Okay, My units again are centimeters times centimeters times centimeters. That's centimeters cubed. Okay, but it's not asking for volume. It's asking for what is the mass. Okay, so, and you got to ask yourself, so mass is what I'm trying to find, but the question is the mass of what? And I'm dealing with 4,600 centimeters cubed of paper, so that's going to be my given. This is not my find, okay? So I start with my 4,600 grams of paper. Oops, 40 centimeters cubed of paper. And what I know is in every 1 centimeter cubed, there is 1.20 grams of paper. It doesn't specify what unit to give me mass in, so we conceivably could use mass here. So it's just simply going to be 4,600 times 1.2, and I get 5,500 grams of paper. Okay, let's try another. Alright, gold can be handed into extremely thin sheets called gold leaf. And you actually will see this on like the state capitals in some locations where it looks really gold, and in fact it's just this really, really tiny, almost an atom thick sheet of gold that's been finely hammered to really, really thin. Okay. So if I have a 200 milligram sheet of gold hammered into these dimensions, 2 foot by 1 foot, what is the average thickness of the sheet in centimeters, given that the density of gold is this? Okay, so let's take a look. So here, I need to, before I can figure out the thickness, I can use this density and this mass to figure out the volume of the sheet, right? This is just like the lab you're doing with the aluminum foil. So if I have 200.0 milligrams, what I know is a 1,000 milligrams is 1 gram, right? And this tells me that there are 19.32 grams in 1 centimeter cubed. So if I plug this in, I get that there are 0.01035 centimeters cubed. Let's just punch that to make sure everybody's good with how to do that. Okay, so I'm going to take my 200 times, it was just times 1, I'm going to divide that by, I've got to put the 119.32 in parentheses, so it's divide by 1,000 times 19.32. I got to close my parentheses, hit enter, and I get this 0.1035196. Okay, I've got 4 sig figs here. So far I can keep 4 sig figs because I'm still doing my mass. I mean my volume, and I'm using dimensions that allow me to get that. Okay. All right. So I have my volume equals 0.01035 centimeters cubed. And I also know that volume is equal to length times width times height. Okay? Let's actually bracket this and show right here. This is equal to volume, right? And I'm trying to find this. So in order to isolate this, I divide this side by length times width, which means I got to divide this side by length times width. When I do that, this cancels out, and I'm left with height is equal to my volume divided by my length times width. Okay, so let's plug it all in. My height, I'm trying to find, is equal to my volume, which is, we just calculated, 0.01035 centimeters cubed, over my length, which is given to me here, 2.4 feet. Now this is feet This is centimeters, so we need to do a conversion. So I've got 2.4 feet, and what I know is 1 foot is 12 inches, and I know that 1 inch is 2.54 centimeters. Okay, so let's punch that. Gotta clear that. So I've got 2.4 times 12 times 2.54, and that gives me 73.152 centimeters for that one dimension, right? And I can take the 1 foot, and I know 1 foot is 12 inches, and I know 1 inch is 2.54 centimeters. Inches cancel, feet cancel, and this is a mess. And I end up with 12 times 2.54, and I get 30.48 inches, or centimeters. Okay, so I'm going to plug those in here. 73.152 is my length. My width is 30.48. It's always best when you're doing this, if you're doing the calculation separately, separate pieces, is to carry as many sig figs as you have all the way through and do your rounding at the very end. You end up with a more precise answer. So first of all, my centimeters cubed up here, I'm going to have centimeters squared up here. So this cube is going to cancel these out, right? So I'm going to end up with just plain old centimeters on top. And then if I were to punch this, I would get 0.01035 divide by, in parentheses, 73.152 times 30.48, close the parentheses, equals, gives me a height of 4.64. Okay. Now this has an exponent here. It's times 10. You've got to be really careful. This is, whoops. This e minus 6 means times 10 to the minus 6 in centimeters. So really tiny thickness here of the gold sheet. Alright, let's try another one. Let's make sure I'm still recording. Okay, I am. Alright. The Italian government is giving Michelangelo's David's a bath. In the newspaper, there was a photo of a person working on the statue, and their hand was half the size of the statue's hand. Shows you how big the statue is, right? If the statue is 5.9 meters cubed, and the density of marble is 2.76 centimeters cubed, what is the mass of the statue in kilograms? Okay, so I got to convert units, and then I've got to use my density to get mass. Okay. So if I have 5.9 meters cubed, and I need to get it to centimeters cubed, right? What I know is 1 meter is 100 centimeters, and if I do that 3 times, I'm going to cancel out my meters, right? Meters, meters, and meters will cancel out the meters cubed, and each time I do this, it's 100 centimeters, which means I end up with centimeters up here, which is what I want, right? So this is centimeters times centimeters times centimeters, and I can cancel that here with the centimeters cubed. 1 centimeter cubed is 2.76 grams. So my centimeters, centimeters, centimeters cannot cancel out with centimeters cubed, and I end up with grams. And if I plug all that in, I get 0.01035 Oh, and I want the answer in kilograms, so let's do one more step. What I know is 1,000 grams is 1 kilogram. Alright, so let's do this on the calculator. So I'm going to take 5.9 times 100 times 100 times 100 times 2.76 equals, divide by 1,000 equals, and I get 16. I only have two sig figs here, so that's going to limit me, and I end up with 16,000 kilograms. Alright, let's take a look at number 20. Alright, a truck designed to carry 34,000 liters of benzene, which has a density of grams per deciliter. What a pain that is, right? It's being considered to carry 24,000 liters of carbon tetrachloride that has a much higher density. If the maximum weight load of the truck is 34,000 liters of benzene, should the truck be considered to carry the carbon tetrachloride? Justify your answer with calculations. So in order to do this, we're going to have to figure out, it gives us the load for, it says the maximum load is 34,000 liters of benzene, but this is not a weight, this is a volume. So we're going to have to use the volume and density of benzene to figure out what the mass is. Okay. So I'm going to start with 34,000 liters. I'm just going to call it a benzene. And what I know is 1 liter is 10 deciliters. Don't use this much, and I want to put this on the test. And that for 1 deciliter, I get 158.5 grams. Okay. If I multiply that out, what I get is that load is 3 times 10 to the 7th grams, okay, of benzene. So that's the max load. This is the most it can handle in terms of mass, right? Is this. Alright, so what I want to see is if I use this truck to use 24,000 liters of carbon tetrachloride, whether or not it exceeds that limit. So I have 24,000 liters of carbon. I'm just going to call it C for carbon tetrachloride. And again, I think I messed up the last one. Alright, this density, you're probably wondering how the heck I got that answer. I have 87.4 deciliters, grams per deciliter, right? Not the 158. And that gives us the answer. Okay, so let's just keep going. So what I know is 1 liter. Here is 1 deciliter. And I know that 1 deciliter has this much mass, 158.5 grams. So this is carbon tetrachloride. If I multiply this out, I get 3.8 times 10 to the 7th grams. Okay, so obviously this is more mass than this, so it's too heavy. This truck will not be able to carry this because it will exceed their load. Okay. Alright, 21. A cup of olive oil. A cup is a volume widely used by cooks in the U.S. 1 cup is equivalent to 225 centimeters cubed. If 1 cup of olive oil has a mass of 205 grams, what is the density of olive oil in grams per deciliter cubed? Okay, so I'm trying to find density, okay, and I know volume, okay, and I'm trying to, I know I need to start with 1 cup, right? So let's take a look. so if I have, let's just pause for one. Alright, I apologize for the interruption. I think I'm getting a cold. Hopefully I'm better by the time my school comes back Thursday. Okay, anyway, so here I have centimeters cubed, and I've got deciliters here. So let's just start. Let's convert this 225 centimeters cubed to deciliters so that I can use my density information. So if I have 225 centimeters cubed, what I know is 1 centimeters cubed is 1 milliliter, right? And 100 milliliters are 1 deciliter. Again, we're using deciliters. I would not put this on the test. Okay, and that's 0.225 deciliters. I could use milliliters on the test, but I wouldn't use deciliters. Okay. Alright, so I know what the volume is, right? So if I have that much, I actually could keep going. You know, I didn't have to stop there. And actually, let's do that. Let's do it all as one big factor label, because I know you love factor label, right? Alright, so let's go back to here. So, what I know now is alright, let's pause. Alright, I changed my mind. This is going to give us our volume, okay? So when I punch this, what I'm going to have is 225 divide by 100. Whoops. $225 divided by 100. Seems kind of silly. I should be able to do this in my head, but I'm tired. 2.25 deciliters, right? Okay, we're good. I was just looking at the answer key, and the answer key looks like it's wrong. So, alright, so if I have I have this much volume, right? It tells me how much mass I have. Density is simply mass over volume. My mass is 205 grams. Oops. My volume is 2.25 deciliters. So my density is going to have units of grams per deciliter, because that's what this is, right? So let's punch it. Clear. And I get 205 divided by 2.25, and I get a density of 91.1, and that is the answer on the packet. Okay, so let's try the next one. 22. In a well-known movie, there is a famous scene in which the hero tries to outwit the designers of a trap by using a gold statue with a bag of sand of about the same volume. Given the density is 19.3 grams per milliliter and sand is 3.1 grams per milliliter, does this seem like a scientifically reasonable plan? Why or why not? Well, what do you think? I'd say it's not, because this is so much less dense that whoever's going to try to lift it would know right away. And of course, this is not as stable a material, so it's going to kind of fall apart. Okay, in the movie, the hero grabs the statue with one hand and appears to handle it quite easily. Given the volume of the statue appears to be about 1 liter, what would be the mass of the statue? Okay, so I have 1 liter, and so this is part B. If I have 1 liter, then I know 1 liter is 1,000 milliliters, and 1 milliliter I'm going to assume this is gold, so I'm going to use the gold's density, 19.3 grams. And if I multiply that out, I'm going to get 19.3 times 1,000, and I get 19,300 grams. Okay, so that's part B. Part C says a mass of 454 grams has a gravitational weight of 4.45 newtons. And the question is, which is about 1 pound. How many pounds would the statue weigh? Okay, so I can take this mass, this is part C then, and I can take that number of grams and say 454 grams is 1 pound, right? Is 1 pound. And so therefore 1 lib pound, okay? I can take this number and just divide it by 454, and I get 42.5 pounds. I'm still looking at 3 sig figs, right? 3, okay. Alright, so that was part C. Now let's look at part D. 1 gallon of milk has a mass of 33.7 kilograms and a weight equivalent to 8 pounds. How many gallons of milk would be the equivalent of the gold statue? So think about how you would solve this before I finish. Okay, so I'm going to start with my 42.5 pounds. Okay, and what I know is there are 8 pounds in 1 gallon. So if I multiply this out, I get 5.31 gallons. So, you know, pretty good haul. Not impossible, but not real simple. Can't do it with my little finger. Okay, let's take a look at 23. So now we're on to type 3 problems. 23, you have some iron, copper, and titanium wire. They're all the same gauge or diameter or thickness, right? Your lab group measured out a length of wire that is exactly 10 grams for each type of metal. So question says, which of these metals would be the longest? Okay, so let's think about this. So if I have the same size piece for the same amount of mass, right, and I have these densities. I have the lowest density for titanium, which means for the same size piece I have very little mass compared to copper. I have twice as much mass for the same size piece, right? So I'm going to have a smaller piece. I need a bigger piece of titanium to equal the mass that I have of copper. So titanium is going to be the longest, and the shortest would be the copper. Okay, so let's take a look at D. So D says, if 1 centimeter length has a mass of 0.15 grams, how long would 10 grams of wire be? Okay, so that's pretty simple. I have 10.00 grams, and what I know is 0.150 grams is 1.0 centimeters. So I have a length of 66.7 centimeters. Okay, let's take a look at E. Alright, it says, what is the diameter of the titanium wire? And it gives us this formula, V equals pi r squared h. So if I'm trying to find the diameter is twice the radius, right? So I'm really trying to solve for r. So in order to do that, let's rearrange the equation. So if I have V equals pi r squared h, and I want to solve for r, I'm going to divide this side by pi h, right? So that r is all by itself, and I can divide this side also by pi h. So r squared is going to be V over pi h. which means R is going to be the square root of V over pi h. Alright, so I'm trying to find the height. Okay, we have the height. I'm trying to find R. I don't have the volume yet, so let's find the volume. So if I have 10 grams, and this is titanium, 10 grams of titanium, what I know from the density is that there are 4.51 grams of titanium per centimeter cubed, 1 centimeter cubed. Centimeters and milliliters are the same, right? So that's going to give me, if I divide that, 2.217 centimeters cubed. Okay, so let's put that into the equation. So it's going to be the square root of 2.217 centimeters cubed over pi, right? My calculator will have a pi button, over the times the h, which we determined up here was 66.7 centimeters. Okay. So if I punch that, I want to take the square root, and that the square root is the underneath the x squared button here, so it's second x squared of 2.217 divided by, in parentheses, pi. Now pi is, my eyes are not working right here, so that's second caret, right, times 66.7, close my parentheses, equals, and I get 0.10 0.10. Okay, I apologize for this. Looks like the answer key might be wrong again. So when I punch it, this is what we should get. And this looks like it's correct. It just verified it. So it's 0.1029, and I have just 2. Okay, let's do the diameter first. So this is my radius, and my diameter equals 2 times my radius. So I'm going to multiply this times 2, and so let's do that here. Times 2 equals, and I get 0.2057, and again, actually I have 4 sig figs. This should be 10.00 grams. So I'm going to go with 4 sig figs, and I'm going to go 0.2057 centimeters. A little different than what the podcast says, but not far off. Okay, or what the answer key says. All right, let's try 24. All right, gold has a density of 19.3 grams per centimeter cubed. A cube of gold measures 4.23 centimeters on each side. What is the volume of a cube? All right, so I can just take the volume of the cube is going to be this cubed, right? So it's going to be, let's just do that, 4.23. I'm going to do it lazy way, times 4.23 times 4.23. And that's going to give me 75.69. And that's going to be centimeters cubed, right? Okay, so the question now is, what is its mass? So if I have 75.69 centimeters cubed, what I know from the density is for 1 centimeter cubed, I have 19.3 grams. I multiply this out and I get 1,460 grams. Alright, last question is, a standard backpack is 30 centimeters by 30 centimeters by 40 centimeters. Suppose you find a hoard of pure gold while treasure hunting in the wilderness. How much mass would your backpack hold if you filled it with gold? And would the average student, if an average student has a mass of 70 kilograms, could she carry the gold out of the woods? Alright, so let's just think for a minute about what we're facing. Alright, so let's figure out the volume we get when we do this. Okay? So 30 times 30, now this is centimeters, times 30 centimeters times 40 centimeters is going to give me 36,000 centimeters cubed, right? And if I have 36,000 centimeters cubed, what I know is 1 centimeter cubed, this is gold, right? It's going to weigh 19.3 grams. And if so I'm still on B. I'm trying to figure out the mass of this gold here. And I know that 1,000 grams is 1 kilogram. And if I multiply this out, I get 690 kilograms. Now, alright, I'm back. So 690 kilograms. Now, if that person weighs 70 kilograms, are they going to be able to carry almost 10 times their weight? There's no way. That's like a 150-pound person carrying lifting 1,500 pounds. No way it's going to happen, right? Alright. So let's take a look at 25. Alright, we have an Olympic-sized swimming pool that is 25 meters long and 25 meters wide. How many gallons of water are needed to fill the pool to a depth of 4.8 feet? Okay, so I have feet here, I have meters here, and I need to convert one of them to the other. Okay, so let's convert feet. So I have and I have milliliters here. Okay, so I have 4.8 feet, and what I need now is 1 foot is 12 inches, and I know that 1 inch is 2.54 centimeters. Alright, and if I multiply this out, I get 146 centimeters. So let's go ahead and convert these meters to centimeters too. So I have 50 meters, and 1 meter is 100 centimeters. So this is 5,000 centimeters, and this would be 25.0 meters, and 1 meter is 100 centimeters. So this is 2,500 centimeters. So my volume is length times width times height, which in this case is 5,000 centimeters times 2,500 centimeters times my height, which is my depth, 146 centimeters. And if I multiply all those out, I'm going to get 1825, and then 1, 2, 3, 4, 5, 6 zeros, 2, 3, 4, 5, 6 centimeters cubed, which is also 1.8 times 10 to the 9th. And I could put this in centimeters cubed or milliliters. Okay, because I got milliliters here, I'll leave it as milliliters. So if I have that many 1.8 times 10 to the 9th centimeters, or milliliters, what I know is 1 milliliter is 1 gram, but I'm looking for mass in kilograms, so I know that 1,000 grams is 1 kilogram. So if I do this, I simply am dividing this number by 3, which means I move the decimal point 3 places, so it's going to come out to be 1.8 times 10 to the 6th kilograms. Alright, a couple more here.